Our today's lesson will tell us about two types of energies, namely potential energy and kinetic energy. In this video, potential energy and kinetic energy have been abbreviated as PE and KE respectively. At the end of this video, students should be able to understand what potential energy means and how it is calculated, understand what kinetic energy means and how it is calculated. We will also learn interconversion between these two forms of energy. Potential and kinetic energies are two forms of mechanical energy. Potential energy is further divided into gravitational potential energy and elastic potential energy. Let us have a look at this water mill used in Mauritius over 100 years ago. The water mill, which is no longer used, is situated at Balaklava in the north of our island and can be visited. It was used during colonial times to grind wheat to produce flour. In this video, we will see water falling from a height onto the water wheel, which as a result turns. Let us see the video. We now look at the water wheel from a physics point of view. We see that water falls from a height. The energy of the falling water rotates the wheel, which drives the grinding machine found inside the building. In physics, anything found above ground level is said to possess gravitational potential energy. And anything which is moving is said to possess kinetic energy. Kinetic energy was known as movement energy in primary school. Any mass kept above ground level possesses gravitational potential energy. This slide shows a huge mass of water well above ground level. This water therefore has a tremendous amount of gravitational potential energy. This gravitational potential energy can easily drive a hydropower station to produce electricity. Here we see a lion sitting on top of a hill. Since the lion is above ground level, it has gravitational potential energy. On this slide, we see a lion comfortably sitting on the grass at ground level. The lion has no gravitational potential energy. In fact, any mass situated at ground level has zero gravitational potential energy. The gravitational potential energy of a mass m situated at a vertical height h is given by GPE is equal to mgh, where m is mass in kilogram, h is vertical height above ground level, and g is acceleration due to gravity, which is equal to 10 meters per second square. This is a very simple exercise on calculation of gravitational potential energy. We are required to calculate the gravitational potential energy of the 2 kilogram mass, which is at a vertical height of 4 meters above ground level. Gravitational potential energy is mgh, and this is 2 multiplied by 10 multiplied by 4, which equals 80 joules. We now move to our second exercise. In this exercise, we have two different masses placed at the same vertical height. We have to calculate the gravitational potential energy of each mass and write down a conclusion. The gravitational potential energy of the 2 kilogram mass is 2 multiplied by 10 multiplied by 4, which is 80 joules. The gravitational potential energy of the 5 kilogram mass is 5 multiplied by 10 multiplied by 4, and this is 200 joules. We see that gravitational potential energy depends on the mass of the object. The larger the mass of the object, the larger is its gravitational potential energy. In this exercise, we have identical masses at two different heights. We are being asked to calculate the gravitational potential energy of each mass and write down a conclusion. For the 2 kilogram mass on the left, gravitational potential energy is 2 times 10 times 4, and this is 80 joule. For the 2 kilogram mass on the right, gravitational potential energy is 2 times 10 times 6, and this is 120 joules. We see that as vertical height increases, gravitational potential energy also increases. So far, we have learnt that gravitational potential energy is equal to mgh. A mass above ground level has gravitational potential energy. As mass increases, gravitational potential energy increases. As height increases, gravitational potential energy also increases. We now move to the second part of our lesson, which is kinetic energy. As mentioned earlier, kinetic energy is possessed by a moving body. In primary school, kinetic energy was known as movement energy. The slide shows a group of students sitting in a class. As they are not moving, they have no kinetic energy. On this slide, the students are running. Since they are moving, they have kinetic energy. The kinetic energy of a body of mass m moving with the speed v or velocity v is given by half mv square. In SI units, mass is taken in kilogram and speed in meters per second. The SI unit of kinetic energy is joule, abbreviated as capital letter J. The slide shows a car of mass 1000 kilogram moving at a speed 10 meters per second. we are going to calculate its kinetic energy. Kinetic energy is half mv square, and this is equal to half multiplied by 1000 multiplied by 10 to the square, which is equal to 50,000 joules, which can be written as 50 kilojoules. This slide shows the same car, meaning the same mass, moving at different speeds. Calculate the kinetic energy in each case. What can you conclude? When the car moves at 10 meters per second, kinetic energy is half mv square, which is half multiplied by 1000 multiplied by 10 to the square, which is 50,000 joule, which can be written as 50 kilojoule. When the same car moves at 15 meters per second, kinetic energy is half mv square, which is equal to half multiplied by 1000 multiplied by 15 to the square, which is equal to 112,500 joule. This can be written as 112.5 kilojoule. We conclude that as speed increases, kinetic energy also increases. This slide shows two different vehicles, meaning two different masses moving at the same speed. Calculate the kinetic energy of each vehicle. What can you conclude? For the car which is moving at 10 meters per second, kinetic energy is equal to half mv square, which is equal to half multiplied by 1000 multiplied by 10 to the square, which is equal to 50,000 joule, that is 50 kilojoule. For the lorry moving at 10 meters per second, kinetic energy is half mv square, which is equal to half multiplied by 1800 multiplied by 10 to the square, which is equal to 90,000 joule, and this is 90 kilojoule. Here we conclude that as mass increases, kinetic energy also increases. So far we have learnt, firstly, what is kinetic energy. Secondly, the formula for calculating kinetic energy is half multiplied by mass multiplied by speed or velocity to the square. Thirdly, kinetic energy increases as speed increases. And fourthly, kinetic energy increases as mass increases. We have now reached the third and last part of our today's lesson, namely elastic potential energy. The slide shows a bow about to shoot. The string is stretched and the bow is deformed. Both store elastic potential energy. This slide shows a stretched catapult, also ready to shoot. Since the rubber band has been stretched, the catapult stores elastic potential energy. On this slide, we see a chest expander. It stores elastic potential energy when the springs are stretched. This slide shows a car suspension system. The spring inside stores elastic potential energy when compressed. Today we have learned kinetic energy and potential energy. We also learned that there are two types of potential energy, namely gravitational potential energy and elastic potential energy. We hope you enjoyed this video. We thank you for your time and attention. Until next time, it's goodbye from us.